Now, some problems are going to be easier to solve if we use what is called the indirect method. And I'll go through a couple of examples, and then in the last one, part C, I'll show you what I mean by the indirect method. So for the first question, if you've got 12 members of a basketball team that are lining up to get medals after a tournament, in how many ways can this be done if there are no restrictions? Well, the number of ways then will be equal to the permutation of 12 choose 12, because all the players are going to line up and get medals. So this ends up being 12 factorial over 12 minus 12 factorial, which is 0 factorial, which is just 12 factorial. And that is equal to 479,1,600 ways that you could line up the 12 members of the basketball team. So now, the question is, if they're lining up for medals, how many ways can this be done if there are 12 members of the team and the captain and the assistant captain must be together? So for the purpose of this, we're going to use blocking. And so the number of ways that this can be done, if there are 12 members, we're going to block the captain and the assistant captain together, so that we're going to consider them one individual. Well, now that we're going to consider them blocked, there are 11 factorial ways that we can line up the team. Now, there's one other little catch here. The captain could be on the left in every or first, or the assistant captain could be first. So for every way of these 11 factorial ways, then there are 2 ways that this can occur, 2 factorial, which is where the assistant captain goes first or the captain goes first. So the total number of ways that they can line up for the medals will be 79,833,000 600 ways that they can line up for their medals. Now, part C is a little bit different, and the question is, how many ways can they line up for the medals if the captain and the assistant captain must not be together? Well, the way we can figure out the ways that number of ways they're not together is we're going to use the indirect method here. And this is what's meant by the indirect method. And in this case, we know the total number of ways that the team can line up for their medals. And we're going to subtract off, using the indirect method, the total number of ways that the captain and the assistant captain must be together. So then the total number of ways that the captain and the assistant captain are not together will be equal to the total number of ways that we can arrange the medal, the order of the medal awards, minus the number of ways that the captain and the assistant captain are together. So then this will be 12 factorial, which is our answer from part A, subtract 11 factorial times 2 factorial. And when we do this, we get an answer of 399,168,000 ways that we can award the medals where the captain and the assistant captain do not get their medals one after another. So now the next question, in how many ways could the letters in the word factor be arranged so that the vowels are not together. So again, we can use the indirect method. So the number of ways that the vowels are not together will be equal to the total number of arrangements that we can, the total number of words that we can make out of this just by jumbling the words. And I'll put words in quotations just because they're really not words, they're just jumbles, minus the number of ways the vowels are together. All right, so the total number of arrangements of this 6-letter word will be 6 factorial minus the total number of ways where the vowels are together. So we're going to use blocking for the 2 vowels, the A and the O. So we're going to consider that as 1 unit. So it would be 5 factorial times 2 factorial. So when we do this on our calculator, 6 factorial is 720 minus 5 factorial times 2 factorial. And so that'll be 480. So we can arrange 480 words using the letters in the word factor, and the 480 ways will not have the A and the O together.